Hello and good morning, CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and the following video is going to be the Cisco Networking Academy Chapter 4, Lab 4-3, where we were working on redistribution. And specifically in this video, we're going to be taking a look at redistribution between EIGRP v6 or EIGRP4 IPv6 and OSPFv3. As we can see, we have our diagram over here on the right hand side of the screen. You'll notice the difference between the actual lab and my configuration is I'm just simply using the the fast Ethernet interfaces here instead of serial interfaces. Again, we're not really dealing with the bandwidth and the delay here, so this is okay, right? I just made a quick substitution, a little easier to cable up. All right, so let's go ahead and dive in. As usual, all the IP addressing has already been configured, and we're going to go ahead and start with step number 2, which is configure EIGRP for IPv6. We're going to start on router 1 with that, so we'll go from privilege exec into global config, and I'm simply going to say IPv6 router EIGRP, and we'll use autonomous system 1. Now, I've already turned on IPv6 unicast routing, so we're not going to need to do that, nor are we going to see an error. So let's go ahead and set our EIGRP router ID for router 1 to 1.1.1.1. Interesting, in the lab, it has us issue the no shutdown command. However, let's see. This is an early release. This is a 15.1.4M10. Router 1 is a 28.11. So if I were to say do show run and include EIGRP, let's see. It doesn't appear that it's shut down. So do show run include shutdown. So we've got two shutdowns, but neither of them with relation to EIGRP. Easy way for me to check, once we enable it on some interfaces, would be to also do a do show IPv6 EIGRP interfaces to see whether or not it's running. So we can type no shutdown, but again, it wasn't shut down to begin with because, excuse me, as of 15 code, the EIGRP for IPv6 is not supposed to be shut down by default, but it never hurts to check just to make sure. All right, now let's go into interface range. We're going to say loopback 0 to 3, and we're going to put all of these loopbacks into the IPv6 EIGRP autonomous system 1. And then we'll go into interface FA00, and we'll do the same thing, IPv6, EIGRP1. So let's do a little confirmation here. If I were to say show IPv6, EIGRP interfaces, you can see that these are the interfaces on which EIGRP is running. Again, the process is definitely not shut down. And let's go ahead now and jump over to router 2, which is also a 28.11 router. So we'll go from privilege exec into global config, we'll say IPv6 router EIGRP1. Let's set our router ID up to 2.2.2.2. I'll type the no shutdown command again. That would be if the EIGRP process was shut down. However, remember, it is not. All right, so now we're going to go to interface loopback 0, which is up top there. This is the loopback 0 interface, and we're going to say IPv6 EIGRP1. And then we're going to do the same thing for interface FA00. Whoops. Interface FA00, IPv6, EIGRP1. And as soon as we do that, we should see an adjacency come up. I'm actually going to give us just a little more real estate here to the right. So I'm going to cover up some of the diagram in the hopes that we can see some more output over here. So if I say do show IPv6 EIGRP interfaces, you can see that we've got interfaces that are up here, loopback 0, as well as the fast Ethernet interface between router 2 and router 1. What about a do show IPv6 EIGRP neighbors? And we do. We've got the neighbor relationship between router 1 and router 2. All right. Do we see any routes? Do show IPv6 route EIGRP. And there you go. So we picked up those 4 loopback interfaces that are all configured over on router 1. So it says verify that router 2 can reach all of the networks. They have a tickle script there. Definitely go ahead and run that. If I were to say TCL, actually let's go back here, TCL-SH, and if I were to get into the tickle shell, I could say for each address. And address is my variable name, by the way. So you could say, I could say for each IP. So if I even I could change that and just say for each IP, and we'll say 2001 colon DB8 colon what do we have here? Cafe colon 1 colon colon 1. I won't put them all in. I'll put a few of them in here. So let's say 2001 colon DB8 colon cafe colon 1 colon colon 2, and then 2001 colon DB8 colon A colon, and let's do 3 colon colon 1, and we'll leave it at that. So then I would close out my statement there. And did I miss a command? Wrong number of args should be for each var list. And did I miss something there? That should be correct. Let's see if it takes it here. And it may be the version of code, because this again is a unrecognized. So we'll come back TCL quit. And always remember to put in TCL quit. If you don't, there's a possibility that you could crash the router actually by issuing other commands thinking that you're no longer in the TCL or the Tickle shell. So be sure to type in TCL quit. So we'll ping those later. Again, that could be related to the code that we're running. So step 3, manually summarize with EIGRP for IPv6. Again, we're not running named mode here. And now where would we do the summary if we were in named mode? Where would that be? Absolutely, you've got it. If we were in name mode, the summary would be done under the AF interface, the specific AF interface that we wanted to use. However, with EIGRPv6, which is not EIGRP name mode, we're going to do it under the interface. So I'm going to transition back over here to our 2811 router 1, and we're going to go into global config, interface FA00, and I'm going to summarize the 4 loopback addresses. And so IPv6 summarization, great skill to practice, and these labs are fantastic. They give us an opportunity to do that often. So let's go ahead and take that opportunity right now. We'll switch over to yellow here. So, excuse me. So we know we have the 4 loopback addresses. Now we know that the first 3 hextets, and I'll write the first 3 hextets up here. So it's 2001 colon DB8 colon, and then it is A colon, and then we have 0, 1, 2, and 3. So the first 48 bits, right? The first 3 hextets, each hextet is 16 bits. So we have 48 bits total that already match identically. So where is the interesting hextet? Well, it happens to be the 4th hextet, bits 49 to 63. And these are the ones, or sorry, 49 to 64. And these are the ones that we are interested in here. So remember, these are hex characters. And we're also using the rule of zeros. So where it says the single 0, it's actually 0, 0, 0, 0, right? And so we have 4 zeros here. Now the 1 is going to be 0, 0, 0, 1. The 2 will be 0, 0, 0, 2. And this is, again, this is still hex here, right? I'm just drawing out the full hextet, 0, 0, 0, 3. So now what we need to do is we need to move these to binary, right? So how do we do that? So binary, and again, we're at the nibble boundary here. So we're doing our subnetting down to the nibble boundary. We're going to leave these guys alone. So 0 in binary would be 0, 0, 0, 1. I'm sorry, 0, 0, 0, 0, 1, 0, 0, 0, 1. 2 is 0, 0, 1, 0, and 3 is going to be 0, 0, 1, 1. Now we get down to the bit boundary, where we come into the bits here and we see that these all match, but right there, it no longer matches anymore. So we have 2 bits that don't, we have 2 bits that don't match, but we have 2 additional bits that do match. So 48 bits here match. We come in here, we've got 4 more that match, 8, 12, 13, 14. So 48 plus 14 is 62. So we know that we're going to be dealing with a /62. Now the question is, what is that going to look like? Well, none of the bit position, none of the bit values are on where we match. Up until the point where we no longer match, none of those bit values are on in this interesting hextet. So our address would ultimately be 2001 colon db8 colon a colon 0 colon, or well, actually, pull that back. Now that I'm looking at it, we could say just colon, because there'll be zeros all the way to the end, slash 62. So that is going to be my summary address. So let's go ahead and clear our screen, and let's make that happen here. So again, very straightforward, IPv6 summary address, EIGRP, autonomous system, and then I want my summary, 2001 db8 colon a colon slash 62. Now, when I hit enter here, is this going to tear the adjacency down, or are we going to see something different happen? And again, here on router 2, show IPv6 route EIGRP, let's take a look at those 4 EIGRP addresses. So here they are, right? You can see we have A0, A1, A2, A3. So let's see what happens when we hit enter. We've got our summary configured. We get a resync, right? Now, it's not a termination of the neighbor adjacency. It's just a simple resync that takes place. Graceful restart. And the information is updated. And then what do we have here? Well, take a look. We now have a single EIGRP route, 2001 db8 colon a colon slash 62. We know that that is the summary route that we just created. So now it asks you to verify again if you can still do the pinging. So go ahead and give it a ping. It should work. I'll throw some manual pings in here actually. So I'll just say ping 2001 db8 colon a colon 1 colon 1. So yep, we've got connectivity there. What about to colon 2 colon 1? That works. Colon 3, and that works. All right. So now we're on step 4 of this lab, where we're going to be taking a look at OSPFv3. Now, they're asking us to use address families. So this is where we're going to see that there's a difference between the 15.1 code and 15.3 code. And it's okay, right? Because remember, OSPFv3 with address families is backward compatible with OSPFv3 without address families. So we shouldn't have any issues there, and it'll give us an opportunity to do both an OSPFv3 configuration as well as an OSPFv3 with address families configuration. So it's got us on router 2 here, and router 2 is a 2811, and do show version. Let's see, we've got 15.1.4 M10 code running on this router. So when I say router OSPFv3 1 and I hit enter, it says invalid input detected. Let's do a router question mark. Yeah, not available in the 15.1 code. If you look back at the beginning of the lab, and I'm taking a look right now, I believe it says the expectation is that you're running 15.2 code or compatible. So again, we've got 15.1 code OSPFv3 with the address families not there. So on this router, that's okay. We'll just simply say router IPv6 OSPF, or sorry, IPv6 router OSPF, and then we'll do it without address families. We'll set the router ID to 2. Wait a second here. Oh yeah, router ID is not set, so let's set the router ID. We'll set it to 2.2.2.2, and then we're simply going to go to interface loopback 0 and say IPv6 OSPF 1. Oops, sorry. And this is going to be area. Area 10 up there. Yep, area 10, and then interface FA01, and we're going to say IPv6 OSPF 1 area 0. Right? So this will be an area border router. So if I say do show IPv6 OSPF interfaces, and we want the brief, I apologize there, interface brief, you can see we've got OSPF running on 2 interfaces. We've got the FA01 interface and the loopback interface. FA01 is going to be area 0, and the loopback interface is simply going to be area 10. 10. If I were to say do show IP protocols, or IPv6 protocols, if I said do show IPv6 protocols, we can see that we are running the non-EIGRP name mode, and do show IPv6 OSPF. And when we take a look here, what kind of a router is this? Well, we see right up here, conveniently, it is an area border router. It's an ABR. And remember, the definition of an ABR is that I have at least one interface in area 0 and one or more interfaces in another non-area 0 area. So this guy, and that is a mess right there, this guy is an ABR, right? Area Border Router, because he's got a non-area 0 area interface and an area 0 interface. So let's clear our screen here. All right. And let's see what they want us to do next. So we're going on to router 3. Now, router 3, as you can see here, these numbers I have up here, router 8 and router 4, as you see them up here, these are just as how I number them in my rack. Again, the host name that we have down here, that's the name to go by for the lab. But I try to keep track here so I can easily refer back. And you can see we're 15.3 code here. And this is a Cisco 1841. So we are definitely going to be able to get the router OSPFv3 1 command in there. So now on router 3, we're running OSPF in named mode, or I should say address family mode, not name mode. OSPFv3 with address family mode. So let's go into address family IPv6 unicast, and they want us to go ahead and set the router ID right away. So we're going to say router ID 3.3.3.3, and so the router ID came up immediately. We'll exit out. I'm going to say interface range LO 0 to 3. So now we're going to take those 4 loopback addresses there that are down here, that are down here on the bottom, right, that are all in area 0, and we're going to activate those right now with the OSPF v3 1 IPv6 area 0. And remember, we need that IPv6 there because OSPF v3 with address families can and does do IPv4. Remember, the transport for OSPF v3 with address families is IPv6, and literally the IPv4 information is communicated using IPv6 as the transport. So we'll say IPv6, because that's what we're doing here, area 0. All right, there we go. So now let's go ahead and go interface range loopback 4 through 7, and these guys are going to be OSPF v3 1 IPv6 area 20. Let me look over there. Yeah, area 20. All right, so those guys are going to be in area 20, and then finally interface FA01, and we're going to go ahead and drop this guy into area 0. Now we should see an adjacency pop up here. Fantastic, and again, proving that you can use OSPF v3 for IPv6 without address families, and you can use OSPF v3 with address families together. All right, they're backward compatible. So let's take a look now. Let's transition over here to router 2, and let's see some of our routing information. Do show, and they want us to run IPv6 route. And so as you can see, we've got quite a few inter-area routes, right? These are coming from area 20. Our Charlie, what do we have there? Or I'm sorry, we're looking for, oh no, these guys are coming from, oh yeah, I'm sorry, I'm on router 2. So on router 2, I'm picking up these OSPF inter-area routes coming from, and I'm wondering why, if I did not update the drawing properly, yeah, because the OSPF loopbacks we're working with are Charlie 4, 5, 6, and 7. And those are definitely the correct loopbacks. Let me take a look here at router 3 real quick. Let's make sure. Do show IPv6 interface brief. May have had a minor snafu when I configured my loopbacks. So 4. So C3. I see the problem. So it looks like these should have been D1. And they are not. So 4 is Charlie 4. That should be D1. Yeah, there's actually a typo over there as well. So we'll stick with these guys for now. No harm, no foul here, right? So we're going to say that the 4 loopbacks, 4, 5, 6, and 7 are simply Charlie 4, Charlie 5, Charlie 6, and Charlie 7. And in fact, I can, well, I'll leave that because this is actually correct, except it should be 0 and then 1. So let's move up here. So that should be 0, 1, 2, and 3. So I apologize. We're going to work with Charlie 4, 5, 6, and 7 instead of Delta 0, 1, 2, and 3. So we do see the correct information, or the information that we should be receiving. And then again, they want us to go ahead and verify connectivity. So now let's make sure. Let's see. Was it something to do with the 2811s and the 15.1 code? So I'll say TCLSH, and I'll say for each, and we'll say IP. And let's just go ahead and say 2001 DB8 colon, and let's ping. So router 3, we're pinging over to, we'll try Baker colon 0 colon 1, and then we'll pick one more address, 2001 colon DB8 colon cafe colon 2 colon 2, and let's see if this works. So we'll close that out, and it didn't like that. So it's got to be something in my syntax, and I'm wondering what it could be. So yeah, it's got to be something in my syntax. I'll have to come back and take a look at this. So we'll say TCL quit. All right, so we'll drive on. We're in step 5 right now. So we're really now, step 5 is where we need to be, or where we want to be, because this is where we're going to be talking about the redistribution component here between the IPv4 and IPv6. I'm sorry, IPv4 and IPv6, between EIGRP and OSPF. So on router 2, if we work our way back over to router 2, this is where we're going to set up mutual redistribution between EIGRP and OSPF. So the lab's going to show you that router OSPF v3 1 command. Well, remember, do show run section OSPF. Remember, we're not running OSPF v3 with address families. This is a 2811 that doesn't support that yet in the 15.1 code, and will probably never will, because the 2811s are end of life, end of sale, end of support here next year. So what we'll do is we'll go ahead and say IPv6 router OSPF 1, and now we're into the OSPF configuration area, and there is the redistribute command that we're looking for. So what are we going to redistribute? Well, we're going to redistribute EIGRP from EIGRP Autonomous System 1. Now, anything here that you think we need to add in. So if I hit enter right now, we'll just leave it redistribute EIGRP1. Let's come over to router 3, and let's take a look now. Show IPv6 route OSPF. So we take a look at the OSPF routes, and remember, I just redistributed these guys here, right, which is my /62 summary, and this guy should have been redistributed as well. However, when we look over here, what do we see? I see an OE2, so that's my redistributed route. We've got our administrative distance of 110, and we've got the default seed metric of 20, so there's my summary. Now, what am I missing? Do you see anything here for 2001 DB8 Cafe :1? We do not. So we're missing the transit or the connected network. And I also just realized I've got .1, .2. I need to update that here. So that should be : :1, : :2, : :2, : 3. So we're missing the transit network here, which is our connected network. Now we picked up the loopback addresses, right? And we've got that summary, so everything is good there. However, no transit network. Now, is that going to have an impact from router 3? So if I were to say ping 2001 db8 colon a colon 1, and let me make sure it's the right address. Oh, sorry, I've got the wrong address there, so we'll let this play out. Okay, so ping 2001 a colon 1 colon 1. And let's see, double check the address, 2001 db8 a colon 1 colon 1. And again, no connectivity here. So why do we not have connectivity? Because I've got the redistribute statement in here, right? But did I include connected? And it's important to remember that if you don't put the keyword include connected, I'm not going to get the connected routes or the transit network. So let's come over here again now and let's say show IPv6 route OSPF. And now we do see the connected route. It's right here. So let's go ahead and check and see if I go to ping, is that going to fix the ping? So ping 2001 colon db8 colon a colon 1 colon 1. No. So even when we put the connected network in there from router 3, I can't get there. And why do you think I can't get there? So we got the transit network added in. That didn't solve the problem. Exactly. Because we haven't redistributed the OSPF routing information into EIGRP. So let's take a look at that on router 2. So let's transition back to router 2. Remember, we needed to have that include connected to get the transit network. So now we're going to go into the IPv6 router EIGRP1, and we're going to say redistribute OSPF process ID 1. Now remember, we're redistributing from from OSPF into EIGRP. And what's particular about EIGRP? Exactly, the metrics. We need to make sure that we have our metric set. So I'm going to say metric 1500, 100, 255, 1, 1500, and that should do it. Now, again, I'm going to include connected, so I get those transit networks. So now let's come all the way back over to router 1 and say do show IPv6 route EIGRP. So let's see if we've got any EX routes here in EIGRP. And absolutely we do. And you can see we've got quite a few. So here are the external EIGRP routes. You can see we've got the C4, 5, 6, and 7. Remember, on your lab, these are supposed to be what you see over here, D, 1, 2, 3, and 4. But we're just rolling with it as it is. And then I'm also picking up loopbacks 1, 2, 3, and 4, Charlie 0, which is here, all the way down to Charlie 3. So a lot of information coming in here from the OSPFv3 area 0 and area 20, and we're seeing all of that information here. It's been redistributed in, so they're going to show up as EIGRP external routes with an administrative distance of 170. Right, and the metric value that we had assigned to these when they came in. So now the question is, if I were to test my ping from router 3, let's see what happens. And actually, let's see, do I have a route? We know we have the route over there, show IPv6 route OSPF. I know I have a route over there because it's part of that /62 summary, the first one we see there. So let's run that command again. And now it works because on the other side, over at router 1 knows how to get back to router 3 because we included that connected transit network here, and all of this routing information is now being communicated over here as external EIGRP routes. All right, so the next step, it wants us to take a look. We'll take a look at the show IPv6 protocols. So do show IPv6 protocols. And when we take a look at the redistributing, we can see here router 2 is very busy. It's redistributing OSPF1. Here is the metric for OSPF1, and it's redistributing it into EIGRP1, right? And when we take a look at OSPF1, the actual process for that, we can see, what are we redistributing? We're redistributing EIGRP1 and including connected. And we see the same thing up here. It's including the connected. So we'll take that off, and let's go ahead and move on to step number. They have us doing some confirmation work here, which we've already done. And let's see, they want another tickle script run, and that is pretty much it, right? So that pretty much wraps up the lab. If we were to take a look, actually, let's see if we can, what do we have going on here? Yeah, all right. So that is going to wrap up lab 4-3. Again, very straightforward, redistributing EIGRPv6 into OSPF, and then OSPFv3, and then redistributing OSPFv3 into EIGRPv6. All right. Hopefully this clears up any confusion you had about redistribution between the EIGRP and OSPF for IPv6 protocols, and I will see you on Monday.